All right, today we're going to be talking a little bit about perpendicular lines. Okay, and we're going to be doing a little bit more proofs today and a little bit of algebra. Okay, so you're just going to have to kind of stick with it and watch some of the things multiple times if you need to. Okay, so the first thing I need you to know is at the very top you have a definition that you need to write down. Okay, so it says the perpendicular bisector of a segment is a line perpendicular to a segment at the segment's midpoint. Perpendicular bisector is that term. Okay, so the main thing you need to know from this first part of this section is that the shortest segment from a point to a line is perpendicular to the line. Remember, perpendicular just meaning it forms a 90-degree angle. Okay, so the shortest segment from a point to a line is perpendicular to the line. Okay, so you're going to be given some examples like this on your test. Okay, and it says, name the shortest segment from point A to BC. Well, we know that the shortest distance is one that's perpendicular to it, and the one that's perpendicular is this guy right here. And we want to name the shortest segment from point A to point BC there. Okay, so the segment that's the shortest would of course be segment AP. Okay, so we want to write an inequality that compares AP and that compares AC. Okay, so it says we want to write and solve that inequality, and an inequality that you could write is, since AP is the shortest, it would of course be less than that AC. Okay, so your AC is greater than AP. And since up top you were given different lengths for that, AC is x minus 8, so you can simply substitute that in. Okay, x minus 8 is greater than AP, which is 12. Okay, now you have this inequality that you've written, and you can simply go ahead and solve this like you would an equation. Okay, so if you want to get x by itself, of course you have to undo subtraction with addition, and x would be greater than 20. Okay, so that means that AC has to be greater than 20. Okay, so that's our first example. Let's try another one real quick. Okay, it says, once again, name the shortest segment from point A to BC. Remember, it's the one that's perpendicular, so our one that would be the shortest would be our segment AB. So segment AB would be our shortest one. Okay, so once again, we want to write our inequality to represent this scenario. So we know AC is longer, so AC would be greater than AB. And then we could plug in our information again. We knew that AB was x minus 5, and that's less than our AC, which is 12. Okay, so once again, you can solve this inequality rather easily by undoing subtraction with addition, and our x would be less than 17. You could have also written it 17 is greater than x. Either way is the same thing. It doesn't really matter. All right. Okay, now we got a few terms to learn. Okay, the first one, 3-4-1, is basically saying that if two intersecting lines form a linear pair, then the lines are perpendicular. Okay, so what it's saying is if you have two angles that are congruent right next to each other on a flat line, that means that these two lines form a line that's perpendicular to them. Okay, so that would be 90 degrees right there. Okay, your second term that you need to learn, and it says, in a plane, if a transversal is perpendicular to one of two parallel lines, so it means if this transversal forms a 90-degree angle with this line, it also forms a perpendicular line with this guy. Okay, so this would also be 90 degrees. Okay, so if you have two parallel lines and a transversal goes through and the transversal makes one line perpendicular, the other is also perpendicular. Okay, and the last one says if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So if two coplanar lines are perpendicular to the same line, so here's the same line, and it's perpendicular to both, okay, then these two lines right here are parallel to each other. Okay, so here's the three terms that you really need to know for this section, and that's about it. Alright, so we got a few proofs that we're going to do, and sometimes these can be kind of challenging, and on your test you won't have to do nearly anything like this. You'll just have to fill in some blanks at times. Okay, so don't be too afraid of these, it'll be okay. Okay, so on the left, we're always going to have our statements. And on the right, we're going to have our reasons. Okay, so our first one is always going to be given. We're going to go ahead and put on our statements what's given to us. And we know that R is parallel to S, and angle 1 is congruent to angle 2. And that is just given. We already know that. Okay, step 2, and we're wanting to prove that R is perpendicular to T. Okay, angle 2 is congruent to angle 3. This is something that we can just deduce. We know that angle 2 is congruent to angle 3 because of our corresponding angles postulate. Okay, so we know that angle 2 is congruent to angle 3 because of the corresponding angles postulate. Okay, next step. We now know that 1 is congruent to 3 because 1 is congruent to 2, and 2 is congruent to 3, so then we can deduce that 1 would be congruent to 3. And we can go ahead and deduce this because of the transitive property that we've learned about. Transitive property of congruence. Okay, and remember, you don't have to memorize these, you just have to know how to place some in a blank on a test. Okay, and then lastly, we can go ahead and say that R is perpendicular to T because two intersecting lines form a linear pair right here. Okay, and those angles are congruent. Okay, so we know that that forms a perpendicular line right there. So our reasoning, you could just say something like two intersecting lines form linear pair of angles. So I'm just going to put linear pair of angles. Okay, I know this is challenging. Okay, just kind of go with it. Okay, we're going to skip you try number 2. I don't feel like it's really necessary for you to learn proofs that are that difficult. Okay, so you don't need to do this one. Alright, before we get going on the last example, I'm going to tell you a joke. What do you call an unpredictable, out-of-control photographer? Think about it. Think about it. A loose cannon. Canon's a type of camera. Anyway. Alright. Okay, on this one, we want to solve to find x in our diagram here. Okay, so this one you're going to have to do a little bit of algebra. You're going to have to take a little bit about what you know to solve for one of the variables. Okay, so on this one we're going to start with trying to solve for x. Okay, we're going to have to solve for both, but we're going to solve for x. Okay, so you could either try to solve for x here, or you could try to solve for x here. Well, this one looks to be a little bit more simple. Now, how could we solve for x? How could we find an equation that would help us solve for it? Well, what do we know about linear pair angles? We have an angle here, and we have an angle here, and we know that that forms a linear pair that adds up to 180 degrees. So what do we know? We know that 10x plus this 90-degree angle would equal 180 degrees. And this line right here, this flat line, would add up to 180 degrees, so that's why. Okay, so then you can just go ahead and solve that simple equation by undoing addition with subtraction. And that would give us 10x equals 90. And then, of course, you can go back and undo multiplication with division. And x would equal 9. Okay, so we've gone back and found what our x was. Now we need to go ahead and go back and figure out what your y is. Okay, now to do that, we have these two equations. Let's do a little bit of erasing here. It's not as messy. Okay, we know that these two equations, 10x and 8x plus 4y, are equal because they're corresponding angles. So we can go ahead and set them equal to each other and go ahead and plug in 9 for each of them. Okay, so we know that 8 times 9 is 72, and put 4y into there. And we know that 10 times 9, just plugging it in here, remember, we plugged in 8 times 9 here, put it in for x. 10 times 9 is 90. And then you have this equation here. So we can undo this addition with subtraction. So we have 4y equals 18. And then if you divide each side by 4, y would end up being 4.5. Okay, so now you have your solution of x equals 9 and y equals 4.5. Now you might need to go back and look at this a little bit. I know it can be kind of challenging sometimes, but we'll keep practicing, so don't worry. See ya.